Hi class, we're back at it again. We're still in chapter 6 and we are learning about the molecular formula of a compound. And in the last lesson we learned that the empirical formula is the lowest, the simplest ratios of elements in a molecule. I like to think of it as the most reduced form, and that while we find the empirical formula from mass spectrometers, which it makes it very, very useful, the empirical formula in and of itself is not the molecular formula. And you guys know that a large portion of the chemical world is comprised of carbon, hydrogen, and oxygen. There's lots of hydrocarbons that have a little bit of oxygen in it. Things like alcohols and sugars, all different things are made up of carbon, hydrogen, and oxygen. Just 6 elements. So I remember the acronym CHOPSIN: carbon, hydrogen, oxygen, phosphorus, sulfur, and nitrogen. Just those 6 elements make up a large part of our body. Most of the molecules, the enzymes, things like that. So finding out the molecular formula is of different compounds is very important when you look at cellular research, when you look at forensic science, when you're trying to identify different drugs in different people's systems, if you're trying to identify if an accelerant was used in a fire and suddenly it becomes an arson. So things like that, finding out the molecular formula of a compound is important. So let's look at an example here. It's C1H2O1. That is our empirical formula. In and of itself, it is not that useful until we find something called the multiplier, which is X. Okay? And whatever you find to be the multiplier, you multiply the subscripts 1, 2, and 1 by that to get the molecular formula from the empirical formula. So this first one, since it's only 1, it's going to be CH2O, and that's formaldehyde. And then you go from formaldehyde to acetic acid just by multiplying everything by 2. Okay, this is the one I refer to as choo-choo. Then lactic acid is multiplied by 3. So we go from vinegar to, you know, that burning sensation that you get into your muscles when you have been working out too much and you get a buildup of lactic acid. I hope you guys are staying healthy and working out. I'm trying to. And then we have C4H8O4, C5H10O5. That is ribose, which is a type of sugar, and then glucose, which is made in plants, and then we use it. It's a major nutrient for energy in cells. So everything that I'm doing there is I'm just multiplying my subscripts by the multiplier in my empirical formula. And this is why you need to have a whole number. You always need to have whole numbers in a formula, because there's no such thing as half an atom or a quarter of an atom or a third of an atom unless it's in a particle accelerator. And even then, we just say that those are subatomic particles. So you need to always have a whole number for your empirical formula as well as your molecular formula. So the formula for finding the multiplier is X is the molecular formula, so the molecular mass divided by the empirical. You know what? I'm going to erase this. Molecular molar mass by the empirical molar mass. Okay? And then you get this number that's you're going to multiply your subscripts by. So you can see here that I was given all of the molar masses. I wasn't really paying attention to them. But if I took this number here, and if I divided it by the molar mass of SCH3U, I would get this multiplier, 1, 2, 3, 4, 5, 6. And the molar mass we can determine experimentally. So this value here of the molar mass is something that we can collect from one type of experiment, and the empirical formula here is information that we can collect from a mass spectrometer. So by using this formula here to calculate the multiplier X, we're able to identify mystery substances. Now just think about all the instances in your life that you've had to have mystery substances identified. From something like, I know that this seems like such a faraway concept now, but when you go into an airport and you get your hands swabbed, they're looking for gunpowder residue and they're looking for narcotics residue, things like cocaine, methamphetamines, and it requires not like the branch of science that is required to identify these substances is chemistry. And it's this type of chemistry here, looking at, well, it's derived from this, finding out the formula. Of course, they aren't using mass spectrometers. The last time I checked, they're about $1 million. I don't know if their prices have gone down from there. But even things like breathalyzers for alcohol and marijuana, it relies on finding and identifying correctly traces of ethanol, of THC, whatever it is. And you don't want to have a false negative. This is also very, very important for just lots of different types of research as well. Okay, anyways, I'm rambling. I really like that science, or that branch of science, identifying mystery substances. Okay, so let's look at a sample question. The empirical formula of a compound is C5H, is it C3? C3H5, and its molecular mass is 82 grams per mole. What is the molecular formula of the compound? I really hope it's C3H5. Okay, so C3H5, let's find out. They gave it to us. So we know that the molar mass of the empirical formula, oh yeah, by the way, I've reduced this to molar mass of the molecular formula over molar mass of the empirical formula. So this molar mass is going to be 3 times 12.01 plus 5 times 1.01. So let's do this in our head. 36.03 plus 5.05 is 41.08 grams per mole. Okay, so that's my that's my molar mass from my empirical formula. Do you see how they gave us the molar mass? So that was determined experimentally. So now I have everything that I need to do to find out what this multiplier X is. So I'm going to divide 82 by 41. Well, okay, look, 82 grams per mole divided by 42.08 grams per mole. Do you see how this unit and this unit crosses out? And I read that formula right because X is 2. So my multiplier is 2. So I'm going to take, there's no really nice way to write it, so I kind of do it this way. C3H5 2 equals C6H10 equals my molecular formula. Woohoo! So that's some sort of hydrocarbon. Okay, and so everything is going to be given to you, whether it's your empirical formula that you're able to find molar mass. So let's look at this question and see what I did. I was given the empirical formula, so from that I'm able to calculate my molar mass of my empirical formula. And then because I was given my molar mass of the molecular formula, I'm able to find my multiplier 2, multiply the subscripts in the empirical formula, and then I get my actual molecular formula. Oh, Okay, so here, example 2, I don't know what happened, but whatever, we'll deal with it. So an unknown compound was found to have the following percent composition. So we have to find the empirical formula. It was 47.0% potassium, 14.5% carbon, and 38.5% oxygen. Okay, I gotta open up to my periodic table because I don't have all of these numbers memorized in my head. And isn't it amazing how many values you can cram into your head? I'm always amazed by how much I can actually memorize. And then I'm always amazed by the fact that I can't remember the name of anybody, except for you lovely students. Okay, so remember, our first step is that we're going to change the percentages to be 100 grams. And then I'm going to divide it by the molar mass. So potassium is 39.10. Carbon is 12.01. Oxygen is 16.00. Let's do this on our calculator. So for potassium, I get 1.20. Carbon is going to be 1 point something. 14.5 divided by 12.01, I get 1.21. Oops. And to be honest, 1.20, 1.21, I would say that they're the same. And then oxygen, 38.5 divided by 16 is 2.41. Okay, just looking at that, 1.2 and 2.4, they're doubles of each other. So even though I'm going to divide everything by 1.20, I know that potassium is 1, carbon is 1, oxygen is 2. Okay, so I'm able to find the empirical formula. Now, what other information can I get from this before I look at my question for anything else? I can get the molar mass of the empirical formula. So it's 1 potassium plus 1 carbon, plus 2 oxygens. Let's add that up together. 83.11 grams per mole. Okay, great. Now this is not enough information to find the molecular formula. I need to be given something else. And a question I always get in class when I teach this is, are you going to give us the molar mass of the molecular formula? And it's obviously I have to. You can't just have this information. And so if the true molar mass of the compound is 166.22 grams per mole, let's find multiplier here, X equals the molar mass of the molecular formula over the molar mass of the empirical formula. And here's a tip. You'll always get a whole number. You always get something nice, like 2.01 or 1.99. If you ever get something like 0.7 or 0.73, you put the wrong number in the wrong place. You always put the biggest number, 166.22 in this case, on top, and then the smaller number at the bottom. And just looking at this, I know that it's doubles of each other. 83.11, if I multiply it by 2, I get 166.22 on the nose. And so the multiplier is 2. And so I'm going to take my empirical formula, and I'm going to multiply it by 2. And I'm going to get K2C2O4. Okay. And that is my molecular formula. Let me just put a box around that. I don't make you guys write their first statement, so just put a box around the answer. I like doing extra examples just because I hope that they help you out. Let me see, make sure that I'm not doing the most difficult one. I think number 5 is the most difficult one. I like letting you guys do a difficult one. Oh, all of them are pretty easy. Yeah, I'm gonna let you guys do all these ones. Okay, so you're probably a little bit overwhelmed by the steps and whatnot, but let's look at what I did over here and you can follow the steps. So in red, this is me finding the empirical formula. Okay, this is me making the sample out of 100 grams. This is finding the lowest common multiple, so the empirical formula. And now I have my empirical formula. I then found the molar mass of my empirical formula, which was then used to find the multiplier x. Once I had that, I was able to multiply all my subscripts in my empirical formula by my multiplier, and then voila, I'm able to get my molecular formula. Okay, hope you guys are well. I'm going a little bit crazy talking to myself and teaching. So I hope I'm not too bizarre in these, and I hope that you are learning and that you're well. Okay, take care.